Hi, I'm Dave Gallagher. Welcome to the Softimage Character Kit. Over the next few hours, I'm going to show you some of the ways that you can use Softimage 3D to make great characters. Now, there's this video portion that comes with the kit, and there's also a bunch of scenes that you can download off the internet. The instructions for getting that will come with the kit. Now, first of all, let's look at the Softimage 3D interface. We'll be looking right at the Softimage 3D interface like this. I'm using version 3.7, but you can use other versions with similar results. They'll be a little bit different. Also, these menus here will be pretty clear, but probably not quite legible. So most of the time I'll be telling you what I'll be accessing, and if I'm using hotkeys, telling you then. But when appropriate, I'll be zooming in like this, so you can get a better look at the menu or dialog box I'll be using. First, we're going to talk about the modeling environment. These are some things that I find useful and helpful when working in Softimage. First thing you might notice is that the scene sort of has a backside, a dark side. The default light is positioned up in Z and X, somewhere up there. Of course, it's invisible. Short of adding more lights to your scene, which you could do, one thing you can do is add one light to your scene. We can just accept the default parameters. Now, with the light selected, go to Constraint, Position, click on the camera. Now the light is constrained to the camera. Wherever we orbit around the scene, the light will stick on the camera, so there will be no dark side. So if I turn on here model mode, you can see the relationship. The light is constrained to the camera. This winds up being really handy. Now, to get rid of the wireframe, we can go into the camera settings dialog box and change the near plane to something like 0.5, 0.6. Now the light icon itself is clipped out because it's too close to the camera, as it were. So let's turn on the show the camera. You can see how close it is, so close that it's not being seen unless we look straight down. Now later on, as you're working in your scene, this light won't constrain to the camera, it'll constrain to the camera interest and actually won't work. So one way we can get around that is make a brand new scene, for instance just like this scene, only without the sphere. Save it and then load it in on top of your other scene, and then if there are no animations on the camera already, this light constraint will take effect. Next, even with objects as simple as this boot here, still gets kind of hard to tell what's in front and what's in back. Quickly becomes a mass of points, and this is a pretty simple object. One thing you can do is use the camera far plane. Set the camera far plane to something other than its default, which is 32,000. In this case, maybe something like 9. Now the boot is sort of engulfed in this fog. Anything beyond the 9 units from the camera will disappear. That's the far plane of the camera, the farthest place that the camera can see objects. And if you use the P key, you can scroll in and out of that. So this is really handy for seeing objects. Even nicer is if you set up a little virtual slider to make this happen. Set the camera far plane to something like 60. Select the camera and then save a camera keyframe. Save key, camera, far. Slide to the last frame, frame 100. Now save another keyframe with the far plane right in our face, something like 1. Save key, camera, far again. Now, if you just drag the timeline, you get this very handy virtual slider. You can quickly position it without even changing objects. So if I slide this way back, it gets lost in the fog, no problem. You can just slide that back and see it. And then if I frame real quick, you can bring the far plane up very fast. So you can use this with wireframe, you can use this with shaded mode, with wireframe optimization, or in shaded mode. Now later on, this slider that you've set up will conflict with the animation. You won't want that to happen while you're animating other parameters and stuff. So another thing you can do is use the custom effect depth frame, and that's under camera here. What that does is takes the distance or the length of the object and adds a little bit, and then clips the camera plane to that distance, and that's both in the near and the far plane. So if I pan in, you'll see that the front is clipped, and pan out, the back is clipped. In order to turn this off, you have to have something selected. So if you have it on and unselect, you can't turn it off without selecting it and then turning it off. A companion effect is depth frame tag, and this does the same thing, only it clips it closer depending on what you have tagged at the time. New to Softimage 3.7 is the ability to clip also the planes not only for the camera but for the front, top, and right views. In the layout window here, these numbers that are set to 32,000, you can now clip to any number you want. So for instance, if I set this to 0, the back side of this boot will clip off, and this can come in very handy. Some things are just easier to do in an orthographic window like this, and so if I drag that back, you can see how that gets clipped out. Another handy tool is the centered vertices command under the edit menu. If you find you don't have this and say the depth frame and some other ones I'll mention, go to Softimage's website and you can download them from there. Now the reason why this one is important is if I tag, let's say, a row in U of points, then I want to scale that. Well, those points are going to scale to the center of the object. So what we could do is take the center and move it around until it's in the right place for our scaling. But it's a whole lot easier. Just come over here, edit centered vertices. Now the center has jumped to right in the middle between all those points. If you don't have any points selected, then it'll go to the middle of the object. But with them selected, do it again, you can then do things like scale towards the center. So this I use constantly in modeling to do things like scale and rotate around a certain point. Now a word about display optimization. If I begin to orbit in this scene, you see that even though it's in wireframe, it's going pretty slow. But if I hide the camera, it has to do fewer calculations and it's much faster. It's not the case on every system that you'll get this kind of performance increase, but keep it in mind, as there can be a very big difference. Also, if you turn off surface, and you can see all the NURBs and patches in the scene change so that they're only displaying their control mesh. So instead of the surface, I'll use my hotkey for that. Instead of the surface, you just get the control mesh. So it has to do fewer calculations, therefore it displays much faster. Now here's a scene with a lot of elements in it. Let's say you want to hide some. I'm going to display, hide, unselected. Now let's say you're working along and you decide you need some of these objects unhidden. Well, you could unhide all, but an easier way to do it would be to go to Ghost, Hidden, and then select the object, unghost it, display, ghost, toggle, and then hide ghosted. So now instead of having to reselect all these items here, we had a whole bunch of things selected. Rather than unhiding all and then having to make a new selection, you can just do that with the hide ghosted and ghost hidden. And I have hotkeys that do that, so I can do it very quickly. Ghost hidden, and then toggle it, unghosted, and then hide ghosted. And that way you can pick things in and out of their visibility without having to always unhide all or go fishing through the schematic window. Now another display optimization trick. If you notice that each NURBS or patch object, if you go into Info Selection, you can see that it has a step, and you can increase that, decrease that, and increasing or decreasing the resolution of the patch. Let's take a close-up look at that. Turn on the lines. So this is how many points it has, you can see, and then in between all the points it has only 2 steps. If I turn on wireframe mode, you can see that a little better. So there are 2 polygons in between those 2 in this NURBS object. Now in Info Selection I can change this to something higher, and that'll increase the number of triangles that the object has. Watch that go down and up as you change those numbers. To make it more, obviously it has more polygons when it's rendered. Now with shaded mode on, you can see the resolution of all these NURBS objects, but the scene updates rather slow. In the shaded view setup, I can go into surface precision here, change the default of 0, meaning make the amount of polygons be whatever each individual object has set, and change that to something low, even as low as 1 for animating purposes. It displays much faster. After the first redraw, then it redraws very fast. Next, about the schematic window. If you have on model and matter mode, especially, things can get very confusing fast. Some options in the schematic view layout window can be helpful. If you change this from for all items to for selected items only, then the relations display gets shown only for selected items. And so this is much easier to look at with the relations being updated only for the selected objects. One recommendation I could make if you're going to make great characters is to have a very strong planning stage. So before you actually go into the modeling, make enough drawings, be sure you have enough drawings, or at least the idea conceptually is very strong in your head. These drawings that I'm going to show you are pretty loose, and I would make more drawings and more detailed drawings, even color drawings, if I weren't going to then move on to the stage of modeling them in clay. This is the character Stuart that comes with a kit. This is my first conceptual drawing for him, and then I made also a full body drawing that I liked. I didn't make too many more. I made a profile of the head and then a profile of the body, and from there started some modeling using the profiles and sort of gobbing the clay onto the paper at the right size, and then building it up from there. The important thing here is, before you get bogged down in technology and the adequacy or inadequacy of any tool that you're using in 3D, that you solidify in your mind the design stage and make sure that you know exactly what you want before you come up against all the limitations, the current limitations of 3D. Here's another character we'll be looking at, modeling or beginning to model his face. This is a drawing for the Lummock character you saw a minute ago. It's very loose. You can see I didn't draw it all the way, but it was the conceptual drawing I used to move on to the clay stage from there. If you're going to be relying on drawings, I would make them more detailed, and important things to have a very clear image in your mind, and not to start off with the limitations of the technology, like I said, but to start off with an image that's very powerful, and to resolve that you're going to actually bring that to life in the software and going to make it just like the vision you originally had in your mind. Of course, a lot of times the character won't be designed by you, but it will be someone else's design that you'll need to realize in 3D. But even then, you'll need to have a strong vision of what the client needs and what the client is expecting. Next, you want to start thinking about the form. Now, there are lots of valid ways to model and to plan your modeling, but I like to use clay and a digitizer. Even if you won't be using a digitizer, though, you may still want to sculpt things in clay, and that's because you can get a very clear idea in your mind of how it's going to look. If you're not going to be using clay, you need to continue this process throughout the drawing stage. so that it won't be just one drawing, it'll be the drawing from multiple angles, and you'll have a very concrete idea in your mind of how this model is going to look. Now this is important for you to split the idea of making the geometry with the idea of the form. First you design the character, then you get the form very solid in your mind before you continue on. Now there's some things to think about when you're modeling in clay and you're trying to model a character. Now the first thing is whether to model half the body or the whole body, half a head or the whole head. Now in this case it was half the body, and that's because they're basically symmetrical. In this case less so because of all the folds here, but I was trying to save a little bit of time. And once you symmetry onto the other side, join them down the middle, then it works fine. In some cases you may choose to do the whole head or body. In this case I wanted to get a lot of character into this guy, and this is the Stewart model we looked at the drawing of, and I wanted to capture the fact that this guy has a slightly different features on the other side of his head, and I didn't want to have that distorted perspective of just having the middle clipped, and so I went ahead and modeled the whole head in this case. Another issue to think about is that you don't have to do the whole model together. You don't have to sculpt it all together. You can do it in parts. For instance, I have a boot that I did for another character, and I wanted to modify it, do it by hand. So I just left that part out, and this is where the boot was going to start. So just stub that off. And same with the hands. Just stop right about where the hands begin, stick those on later. Now the head doesn't have to be the same size as the body, obviously. It's not together, and it's not even in the same proportion at all. This is the head for that body. They can be much larger, much smaller. You can scale those afterwards. If the area is less important, for instance, this neck portion was going underneath the shirt, so it wasn't a really critical connection. So it's a really good candidate to break and start a new object. You can use a couple of different substances for this. I like to use plastilina. It's the gray kind. It's reusable, so after I don't need the model anymore, you can mash it up and make something else. Let me show you those. This kind is Roma plastilina. This is the kind I use. It's the reusable kind, and it's very good quality. The other one is Sculpey. A lot of people use. It's a little bit softer, but you can make good characters with it, and you can fire them hard in an oven afterwards, and so they become more permanent. You can mark on them with a pencil afterwards instead of an X-Acto knife. So those are the things you can use. Also, the size you model at is relative to the amount of detail that you want in the model. For instance, this is a cartoony character. It wasn't really necessary for me to model very big like this guy over here. So I could do a much smaller and still get enough data. Also, I want to show you how this one, I'm doing this a lot lately, where I model a little bit over half the head. And this way I can not get the clean break right down the middle, because sometimes I guess those distances kind of wrong. This way I continue on, but then I kind of fade off. It gives me a better orientation. Now if you do model exactly on the half, then you can lay that down on a mirror and look at it that way by just rotating the whole thing. So those are some of the ways that you can model in clay, some of the things to think about so you can do the best job you can. Now once you're satisfied with the form, you'll need to start thinking about the topology, that is, how the points are arranged on the surface to make up the forms that you've made. Now with polygons you have your own issues, how the polygons will flow, where they will break apart into numerous rows and where they will join back together. But with NURBS, it's a different story. Although you have fewer points overall and it gets subdivided at the render time, it's really a very static shape. It's really a very static form. It has two directions to it, and any shape that can't be caught in that basic format really needs to be made up of multiple surfaces. Here's a piece of paper. It's kind of like a piece of paper that you can stretch any direction, but there's only so much you can do with a shape that's basically this. You can join the edges and make a tube. You can close these up and make a rounded top, rounded bottom. You can open them up. You can join them in different ways, but as soon as you want, say, an arm sticking out of this tube, then you're out of luck. You need to make a separate NURBS object and then attach that through one of the ways we'll talk about in a little while. So with polygons, you have freedom to branch in and out to the areas where you need more detail. But with NURBS, it's really a pretty static system. So you need to think of different ways that you can wrap that NURBS surface around these models that you've sculpted or cast. So I'm going to show you some of those topologies. I've rubbed out the lines here, but grab my X-Acto knife. This is a separate surface, so a break here would actually be preferable. So if I want more geometry on the leg or more geometry on the torso, I don't have to continue on underneath here. I can just stop the leg up inside of here and stop the body there where this loincloth thing begins. I don't even have to use the same amount of points on this part. I can use fewer. So these don't necessarily have to match up. They could, or I could use more. And the legs, they don't have to really match up. So breaks in articles of clothing is one way you can save yourself a lot of hassle. Another thing is breaks in the actual clothing, in the seams of the clothing. So right here there's a seam, and what I've actually done is made a break there so that this front shirt surface continues on underneath this arm surface, and they just come together nicely and make a little bump. And so there's a seam there in reality, and there's also a seam there to make things easier for texture mapping and UV texturing. For the arm here, notice that there's fewer lines going this direction for the arm than in the shirt. And so there needed to be a little bit less detail, so you can get away with that. Same thing down here. The leg went underneath the shirt, so you can have a different surface going this way. Another thing you can do is do creative things for lining up geometry going different directions. So in this case, the chest all the way down to the arm to the wrist was one surface that wrapped around the shoulder and comes down. And the break is right here in the chest. And that surface actually went underneath, all underneath here, and came up back on the other side. So this thing was one continuous surface. And that means that this shoulder part, which sees the most amount of bending during animation, is going to be clean and not going to show. For instance, the normal way would be to have a blend here coming off of there. This would be a separate object, and you would somehow connect it to this surface. Alright, but we don't have to do that. One thing you can do, and this is what I did in this case, is even though this is going a different direction, I matched up the number of points here going this way with going that way, and then I connected, if it were B-splines, the overlapping points here, or if not, if NURBS, I could just use a transparency map on the edges, and by magneting these points together I could get this seamless look all along here, and so I could have this very complex situation where I had an arm coming off her chest and coming down this direction. That's one trick you can do. We'll look at that in the computer in a few minutes. Now heads, faces, they're one of the more difficult things to deal with. This cartoon character has basically a top to bottom layout, and so rather than going radially out from the mouth, having a pole in here, having one of those ends of the piece of paper coming in here and going out to the back or to the neck, start at the top. So you can see at the top there are lines coming to one point. All these lines coming up the head all converge in this one place. And that's the pole, or the one pole. The other pole is at the neck, and you can either stop here if it goes under a shirt or something like that, or you can continue on if it needs to be seamless with the body. So this whole surface, except for the ear, which is attached on later, is continuous from top to bottom. And if you need to add more detail, you just add more lines one way or the other. And when you get to the inside of the mouth, you need to have many more points along here to go inside. And what you can do is put a transparency map in there so it actually disappears, so it looks like the mouth is deeper than it is. So you don't have to use too many points in there. So that's one way that I like to do heads. But if the head is arranged so that the mouth is very prominent and it's not quite so tall, you could radiate out starting with a pole inside the mouth and thus going around the mouth, and you can see how the mouth is kind of a round shape, and that sometimes is very beneficial. Like the ear, obviously very round shape, very complex. What you want is to have the lines in a circular pattern, and that's what I did here. Started actually not in the very inside of the ear, but right here, right there, and then circled out, wrapping in and out, but getting all the detail of a very complex ear, and so that one edge would travel all the way around here, and so you'd have a very nice, well-defined ear. The surface connection of the ear to the head is actually quite simple. It's one of the easiest connections because that part of the head is not really very complex. And so this is a good option for ears. Okay, this next shape is very complex. Has 3 points to it. How would you realize this in NURBS? Well, the way I did it was start one pole here, spread out, and then wrap around to the thumb. So that way there aren't two surface connections for the pinky and the thumb. There's just one for the pinky. Geometry flows down, wraps around, and up the thumb. So there's more lines going vertically along the thumb than you need because you have to have all that up here. But it makes for a very nice seamless connection. And the pinky can be attached with one of the surface connection techniques we'll talk about in a little bit. But that way you can get a very nice looking NURBS hand. You don't need to use quite so many points as you would with polygons. Next we'll talk about this body, cartoon character body, and this is one of the trickier methods. You start at the wrist, or in this case right at the arm stub, and you wrap around the shoulder and then down the body and down the leg. So it's actually on one half of the body, one continuous spline from wrist to ankle, if you want to do it that way. And what you do is along this edge, and then the inside of the leg. So it's the inside of the leg and the outside of the arm. You close them by magneting extra points if it's B-splines. Or you can do it with NURBS, it's a little tougher. But you close that together artificially, so it's not actually a closed tube, it's an open tube, but it looks close, all along the arm. And then right toward the neck, you split it open, and then it goes down both the front and the back. So you can picture that. I'll show you that a little bit later in the computer. You come together again at the crotch, and then down the inside of the leg. And so when you put the other half on, you can magnet those points together across the chest here and the belly, so that it actually looks really good and stays together when you're animating. And the only tough areas with this one are the crotch, which normally you don't see anyway, and then the underneath the neck. But if you have a neck stuck onto that, you don't notice that. You don't notice that anyway. Now on this hand here, this is a little bit old. This is a few years old, but like I said, it's a sculpt of my hand. And what you can do is draw the lines on. This time you would want to use a pencil. You draw the lines on the fingers, and then once you're sure that's going to work for each finger, you just continue the lines, even though that there's the edge of the hand will be right along there, just where the finger starts and the hand starts. You continue on, and you make basically a hand with more lines than it needs to have, with more curves. and so those curves look like they're continuing. And you grab those edge points. If these are B-splines, it's much easier because you have those edge points. You can magnet onto there, and it actually looks really nice. It looks like it's a continuous surface. The only tricky part is between the fingers. That doesn't look so good. So if you're going to have a view like this, then you're out of luck. Of course, polygons, very good for hands because you simply break into triangles in this area and resolve all that way. But if you're going to use NURBS, this is a very good way to do hands, and it actually works pretty well. For the thumb, you can do that wrapping technique where you wrap around this way to the thumb, one continuous surface, or like I did this way, use a surface connection technique to have the bottom of this thumb be a separate surface and be attached onto the hand. So that's the way to do it, and it works really well for UV texture mapping. We'll get into that a little bit later. Now going back to this character, we talked about ears a minute ago, but we could have included the ear into the geometry of the face. So if we had enough points, we could flow that in and out around the ear and caught all that and not had to have a separate surface. But you need to weigh your options very carefully, because remember there are two opposing truths to NURBS. That is that the more surface you cover with the NURBS surface, or the more area of your model, the more dense and the more complex it has to be, because it has to catch the most complex part has to be defined, and all that extra data goes all around the rest of the model. So for instance, you have to have a lot here in the mouth. Well, that's going to go all the way around to the back of the head, whether you need it or not in the back of the head. Same thing with the ear. If you were to include enough geometry to really capture this shape, you'd have a bigger mess of points. So the smaller area you can define with a NURBS surface, the better it's going to be, or the easier it's going to be to edit. And the opposing truth is that the more discrete NURBS surfaces you have, the more you have to resort to all these not so good connection techniques to get them together. This one wasn't hard, but some of the other ones are hard and don't always work perfectly. So you want to keep your NURBS surfaces as small and discrete as you can. On the other hand, remember, if you have too many, then it gets difficult as well. Now the actual placement of the curves on the object, of the lines, is actually pretty tricky. This is maybe the minimum amount of points that you would want to use, but if we ignore this layout that I had before, and let's say the arm is going to be separate, okay? So smudge those out. Well, how few can you get away with just to make this form right here, discounting these other parts? Well, you have a curve that you want to go like that, so you definitely need one there. You definitely need one there, and one there, and one there. If you try to take out one of these curves, you're going to have a really hard time making this shape. And so what many people do in NURBS is really wind up using quite a few points. So you wind up using maybe this many to make sure that you have this curve and it's actually going to look just like this. Okay, so but there's a lot of mistakes that can be made, especially when you get into where the creases are and that. For instance, assuming again this is one continuous surface, how many are you going to put down here in this crease? If you put one, and then you put another one here, this time we're thinking about the surface going this way, and you put one here, and then the next one maybe goes here and here. If you're going to do that, then you're probably going to be disappointed with the shape that you get in here, because it's probably not going to go like that. It's probably going to be much more bowed, much more round, and not have the character that you put into this. So really, you might want to put two down in the valley. So maybe something like that. And then rather than waiting till you're way up here on the surface, start maybe down here, then have another one right there. So wherever you have an area where you're going to want some extra detail, you need to double up your lines, and that way you can get that detail. So for instance, here's a collarbone. Do you want to put one line and make it very simple, or do you want to put two at opposite ends of the crest? And again, the more you get to know NURBS or B-splines, whatever patch format you're using, and how it will flow, the better you'll be able to mark things up for digitizing. Because just because you put lines on it, on this thing, doesn't mean that when you put the points in that it's really going to look like it. In fact, in most cases, it's not going to look very nice when you first bring it in, unless you've been really careful about how you mark it up. And so, let's talk about this stomach area. Let's say I put one there, because that's the edge, and then I put one there, and there, and there. Well, again, chances are it's just not going to look just like this, because you have a tighter slope here and a more soft slope on this side. So what you'd want to do in this case is put two on either side, and then maybe move that and have them like that. And this way, this would be about the minimum amount of curves that you could get away with to make up this shape, and have it be a true representation of what you've made physically in the clay. Unfortunately, the most difficult thing to digitize is something as complex as a human head. Now, here's a example of the Stewart character, and I digitize them in an unusual way, and that's using a very light geometry for the head. You'll see that there are just a few lines going either direction. And the reason I did that is for several reasons, but if you have too many points close together, like as many as you would need to catch all the detail in here and in the eyes, you get that too close together, what tends to happen is you bring the digitized data in and it has a very ripply appearance, and it takes some work to get rid of. So rather than deal with that, basically digitize it much lighter for the areas that are light, and then attach these high resolution parts on top of it afterwards. Now, in the model that I include, I actually just use shrink wrap. I just use shrink wrap on the edge points of basically this patch here that goes over, or this NURB surface that goes over the underneath the under portion of the nose and stops. So this is a separate area, and the same for the eyes. They're separate square NURBS patches. The layout was designed for basically the edge suction plug-in or something along those lines, where the underlying surface, as it updates, then the edge points all along here will update with it, and so you'll have this smooth connection that continually updates. Okay, now let's say you're not going to be digitizing, you're not going to be using any clay models or kets that you can digitize, but you still like to plan ahead. One thing you can do is take a copy of your drawing, like this is the Stewart character, sort of anticipate how you would mark it up if you were using clay. So what you would do is just begin drawing lines, and this way you can anticipate what kind of needs you're going to have as you begin to actually make the geometry. You can try to anticipate how many curves you might use and where they would be placed, and especially in areas like, let's say we were going to do this wavy cloth area, you could mark on it like that. Try to guess where you would put the lines, and sometimes you can get some helpful experimentation this way. For instance, on the heads, let me show you this. I went back and found some of the stuff I'd done for the Stewart character, trying to decide how I would lay out the geometry. Should it be radially from the mouth, or should I do it top to bottom with some sections cut out and applied later? And so I've drawn lines on here, and after I try to guess what the best way would be, then I can see, well, how many lines does it take, and what will be the best format, which will texture better, which will animate better, and so this can be a very helpful planning stage, even if you're not using clay. Here's another one I found digging around, just trying to figure out, well, here's my shape, but how many curves is it going to take to make up this nose here, and so on. And even if you don't get it right on, if you get it close, it'll still be instructive for you to figure out. Now we'll take a look at some of these topologies in the computer. This is the giant here, the first one we looked at. You can see that this is a very light NURBS model. This is one I did quite a while ago, and this is a good example of what you can do with very few points, but for something where the target resolution is not going to be very high. So for internet delivery, gaming, that sort of thing. So you see the hands. The hands are just sort of loosely connected to the arms, and the arms and the body area is very light geometry. And we're in depth queue mode here, located right there. In the depth queue mode setup box, you have a couple of options. This slider is to determine when the fog begins, and see it's behind the camera now, and then you can set it to begin after, so it becomes bright. And if you set it very short, you can see how you can control the depth of that, and far away then it will look just like wireframe. And I like to set it to gray here, but normally you get black. So again, each of these lines here, except for this one, is joined on or very close to a spline going the opposite direction on the body, and so we get a sort of connection between these two parts. Even though if I turn on the edge flags there, that's in show edge flags, you can see how the object begins here, goes underneath, continues there, and this is separate, but you can make it look like they're one continuous one. The legs are separate geometry. The beginnings are covered up by the loincloth. So this guy was a good example of what you can do by adding some clothing and making it so you don't have to continue geometry and don't have to make a surface connection between the legs and the body. And also an example of how you can join geometry going two different directions by lining up the points and using magnet located in the layout box, and you just turn it on like this. We'll be going over later how to use this in more detail. The other topology method using clothing was to actually use the seams in the clothing. And here you can see the layout of the Stewart character. There's two front portions of the shirt. These could have been joined and wrapped around right around to the back side. As it was, I just left them as separate pieces. You can see how they're just tucked up neatly against each other in the places where there are seams. And you can do that several ways. You can do that by hand, or you can extract a curve out of here and then cut it and use that as one of the base curves for the other object. But the important thing is that you align them in some way. The arm part here is actually, if I hide that, you can see how that looks underneath. That actually this front shirt comes over like that, and the back was supposed to too, but I never got to that at this point. And so this part here is just laid over that. And the reason I did it that way, these U and V lines now will correspond exactly with how you would expect fabric to flow. So basically I've arranged this to flow so that if I put a fabric texture on here with UV texturing, it would look very natural with the texture going this way, and then for the arm piece they'll go that way. If I were to wrap this around like I did with that other body, flowing in from the shoulder down through the arm, then UV textures would not have been a very easy possibility. The belt here didn't start a new object or didn't make a break, but underneath there was a good place to begin the leg. I switch to wireframe, you can see where that begins. It doesn't need to go up too much further than that to be convincing. And now this part of the leg here, you can see how it splits apart and is artificially joined. And let me go back in shaded mode. You can see how I've just kind of tucked these points together here so that I can make a seam up there, even though the object isn't actually closed, so that I can actually branch it open at the crotch and go forward around here and then back around here. And that way the pants also flow in a natural way like you would expect the material to. And if you were to put a fabric texture on here in UV, it would look very natural. Again, these just tuck right under the boots and the object can end right there. You don't have to continue on. So this is an example of using the seams in clothing to help you be able to break your NURBS into multiple objects for simplification. And it's also a good example of using the NURBS to your advantage, looking forward to the texturing stage when you can use UV textures to simulate fabric and those kinds of surfaces where the built-in surfacing texturing of NURBS comes in very handy. Now here's that simple cartoon character's head. There's its top to bottom arrangement. Joined at the top, actually not at one point but one line. That's something you can do. Instead of all going into one point, if the area is a little bit elongated shape, if this is more of an oval than a circle area, you can have them join into a line. And you kind of have to build that manually. Otherwise you can just go into here and turn on capping at the top, and that will do that. So this pulls a little bit because of the special oval shape, so I'll just undo that. So it has a normal top to bottom layout. I have edge flags on so you can see that the U edge is on the bottom and the red goes up the left side, and that's how it should be for texturing, because the bottom of the texture map will go along the green or U line. The way to make the mouth, again, with this sort of character, is to increase the resolution right around the corners of the mouth, so you can go inside the mouth. Same thing with the eyes. This has very simple eyelids, so it required very few lines. It's very simple shapes. The ear is connected on afterwards. We'll look at those surface connection techniques in a little bit. The inside of the mouth doesn't have a lot of definition, so in order to do that you'd have to add several more curves, which is an option. One thing you can do is just add a transparency map or opacity map here that turns this part transparent so that the lips basically end, and then you see inside the inside the head, or you can either turn off back culling so you can see the back side of the head and the shadows that would go in there, or you can create a new object, inside of the mouth object to sort of float behind there. Now look at this ear layout. Again, they're arranged in a circular pattern around this point in the ear, so that by the time the rings reach the outside of the ear, that they're arranged just right, so that you can get all the curvature of an ear. Again, the green U line is on the base of the texture map. The UV texture map will begin there and end there, and that the seam of the texture map will be here in the least prominent place. So you can see how those points are all arranged, that the layout is optimal to capture all the detail of an ear. If I turn on lines, you can see where the actual points lay. I feel this is very useful topology for ears. Now look at that cartoony hand. NURBS flow from this pole to a pole there at the tip of the thumb rather than at the bottom, so you can make a nice clean connection between a thumb and the hand. Pinky is a separate object. Notice that these are actually inversed. The red should be going up the seam there, and the green should be there for the texture map to lay properly. You can always just rotate things afterwards, but I find it's easier to maintain consistency. So to change this, go into Effect, Curve Controls, and swap the U and V. Now you'll see it's inversed. Change color. The best way to do it is to turn on normals before you enter that box. And you can see you can swap. Then you'll need to inverse the U, not the V. And that way you have the green, or the U, at the bottom, and the normals facing outward, and the red along the seam. Next, with the cartoony body, you can see that the beginning of the NURBS patch on one side of the body, the NURBS surface, begins at the toes. The seam goes along the inside of the leg, and again, that's not closed. It's actually open and artificially magneted to look like it's closed, because at the crotch here it splits apart into two parts. Front, one side goes along the front and the one side along the back. Might be easier to visualize if I hide this. You can see how that works. Together again at the shoulder, or at the neck rather, underneath the neck. Optimally I'd probably add another curve in there to get that, but the neck laid over that, so it worked alright. They come together down the outside of the arm to the wrist. So this method can work really well. Let me show you the other side of the body, and in shaded mode you can see how those join together and are actually pretty seamless all the way up until you get to the crease areas. This character is a good example of how many NURBS characters are done in segmented pieces. All these elements here are separate NURBS surfaces, so this one here wraps around to the back, goes all the way down the front and down to the crotch, and defines the front half. These other parts are separate. For instance, those little pieces there, the surfaces are just aligned so that they abut up against each other, and then the shoulder is a separate piece, and the arm going underneath there. The shirt ends right at the wrist, so that's convenient to have very light geometry for the arm, and then the heavy geometry for the hand. The legs too are segmented. The main thigh begins right there at the connection with the body, and stops right after the knee where the boot starts, and there's a separate piece laid over it. All these things are NURBS geometry, and the boot goes from the kneecap to down to the feet. Now the head is a good example of with the poles at the top and the bottom, a grid-like layout. And we'll talk more about the eyes and hair later on. Now this turtle character makes great use of the fact that most of its body is hidden inside a shell, so its limbs, its arms, its legs, its tail, can just start right below the hole in the opening of the shell, and that works just fine. The top shell is laid out just like this, and the head is laid out in a circular pattern around the mouth. So that way the mouth shape is enhanced by the geometry. Instead of fighting with getting lots of curves down inside the mouth, this is a very natural way to organize characters like this that have a large mouth at the front and then not a whole lot of detail down the length of the head. Here's another example of the mouth the geometry radiating out from the mouth. Makes a very natural environment for this mouse character here. This one is for internet delivery, very small resolution, so the connections with the arm, the ear, the eye, very basic, and since it was going to be very small. This is a good example of that sort of topology. This is a superhero character, Vigilant. He's made up similar way as that giant character. You see that the arms and shoulders and chest section is one piece again, the neck coming off of it, and the abdomen area being stuck on underneath it. Very similar fashion. But this time the legs are different. The legs are actually connected and wrap around the crotch area, like this. This is a good way to make sure that these crease areas actually won't come apart because they're the same surface, and then the abdomen area is connected on with a surface connection technique. So the arms and the legs in this case are similarly designed to put the areas of stress in areas where there isn't a connection. Again, with the shoulders there's a clean area, and right around here it's one continuous NURBS surface, so there's bound to be less problems than there otherwise would be. Feet were probably designed a bit problematically. You see that the pole is actually underneath, like so. So unless I model a sole on there afterwards, then if you happen to see the underside of his foot when it's bending, then you're bound to see some creasing there, because you see it doesn't really allow for bending in the regions where the toes are. Another view of the chest area. You can see how the red V line travels along underneath the chest and actually connects on to the back, and how the beginning of the U is over here on the wrist, and the surface goes to the other side. Looking at this same character's head, you see that it's again a pull at the top to pull at the bottom at the neck layout. It's very similar to that cartoon character, only now you need many more lines to make all the subtleties in the shape. There's a lot of subtlety around the nose and in the eyes. You have to add enough geometry so you can have blinks and that sort of thing. Then around the mouth, you want to include enough geometry so you can go inside of the mouth again and define that area there, and that requires quite a few curves, as you can see here. There's starting with this top lip, 1, 2, 3, 4, 5, 6, 7, 8, 9 to go to the lower lip, so quite a few points. This is has some advantages, this particular topology for heads. That is, the texturing works very well, because if you use UV maps and NURBS, then you won't be stuck with a topology that is radiating out from the mouth, and that becomes very difficult to texture map, because the texture has to also go in a radial pattern, since with NURBS the UV textures are built into the geometry. And the other nice thing is that the only surface connections are for the ear and for the neck. So this method works pretty well. The drawback is that it's difficult to model because there are so many points. Next we're going to talk about the actual digitizing process, getting the data into Softimage if you're starting with an external source. Actually going to digitize, what you do is situate your object like this near the digitizer, but not too close. This is actually a little bit too close because the digitizing arm is torqued as I'm trying to reach the backside, and I reach the limits of its ability to rotate. The digitizer I'm using, by the way, is Microscribe 3D. It's a very good one. Lots of other ones to choose from, but this one is good. It has a free-floating base. You can place it wherever you like, which is very nice. But you may also need to lock it down by putting clay under it or next to it. So you can do that, put it in place, put a couple more. Same thing with the model. You don't want it to move at all while the digitizing. It's okay if the table moves a little bit, but you want this to stay very stationary. And so I've put clay underneath it, kind of, to keep it from moving at all during that process. Normally, by the way, I would hang the leg, since you want to get underneath here, I would hang it actually over the table. I'm not going to do that now, but in that way you'd be able to reach the arm underneath the leg and get all those points under there, and so you can digitize it all together. But I'm just going to digitize this one little section of the arm so you can see how that process works. And I'll show you the software in a minute, but basically I've prepared it to take a point, and I'm going to put the arm on the first point of the arm, and I put my hand on the keyboard, or you can use a foot pedal, and I'm hitting a point every time I put the digitizer exactly on the intersection between the lines going the one way and the lines going the other way. And you can hear that little audible cue that says that a point has been taken. When I'm done, I hit another key and make a line out of it. In this case, it's a NURBS curve is what we've made. When you're digitizing, you don't want to drill the tip in too far into the clay, because that'll make a dent, and obviously you won't get an accurate reading of the surface. We continue on making the curves, and after the curves are brought into Softimage, and there we can skin them together to make the surface. Okay, now I'll show you how this process works in the software that I happen to use, which is Digispace 3D from Western Data Technologies. It's a program mainly for digitizing either in NURBS or in polygons. Here's the line that we just digitized a minute ago, and I'll go ahead and make the next one. And when I get to the end, I hit another button and creates a NURBS spline. See, it passes through the points, and we'll get a really nice tight relationship between the surface of the clay and the NURBS curves. You can see that this particular program shows you the position of the pointer and its orientation too, So that's really handy. You can tell where you are at all times if you're going to redigitize a point, for instance, and that kind of thing. From here, save it out as an IGES file. Once I digitize all the splines in the arm, for instance, or any given section that I'd like to digitize at the same time, and save it out as an IGES file and bring it into Softimage. Now here are the curves after being translated in Softimage. This is what they come in looking like. It won't make a model file, it'll make a whole scene file, and this is how it comes in. Now we're going to talk about making curves from scratch within Softimage. Most organic shapes in Softimage start off as curves. There's linear, there's Bezier, there's cardinal, and NURBS. And they all have different properties and functions. After you make the curves, normally you skin them or revolve them or use another function such as guided extrude or four-sided to make a surface out of them. So let's talk about the different curves and what their properties are. First I'll talk about the Bezier format. Bezier will be familiar to you if you've used 2D illustration packages. When drawing it in Softimage, you click and drag to make handles, and click without moving to make a harder edge, even though the handles are still there. And the handles are nice because you can edit them later and have fine control with a few amount of control vertices. If you want to move them, you can use the M key or edit move point. If you use the right mouse button, you can move them without dragging the handles, like this. If you actually want to edit the node so that it becomes a hard edge instead of smooth, use Edit Coordinate, and then click on one of the nodes. So if you choose Discontinuous, for instance, you'll get a hard edge. And this time you'll be able to edit these handles, and you'll notice they turn light blue. Mirror is the default form, and that's blue. That means as you drag that both sides will have an equal amount of tension. With collinear, those act independently like this, and those handles become purple. Also in Edit Coordinate, you can change a segment so that it's linear instead of curve. The problems arise when you want to skin Beziers. There is no Bezier format in a skin, truly. There are some other oddities. For instance, if you go to Edit Coordinate, let's make sure that this one is discontinuous and make that into a definite hard edge. So drag those like that. Now if I want to duplicate this, and I want to drag this over like that, duplicate, drag. I'm just using the D hotkey for that. Now we have a couple to skin. So I'll go Surface, Skin. I'm going to select those. Right click. Now with patches we can choose between linear, cardinal, and B-spline. Normally you'd want to choose something like B-spline. Now I'm going to hide everything else. Now the strange thing to learn about this is that the points where you wanted it to be smooth are actually hard edges. So you see how that becomes a hard edge, even though that was definitely one of the areas that we left smooth with the Bezier controls. All the actual lines are going to be hard edge, and that's because they're not just one control mesh row. The actual curves of the surface are stuck together so that they look hard. And you can verify this by going into Effect, Convert, and choosing NURBS. Now that it's NURBS, you can use Effect, Reparameterization, and well, let's cancel that. Go into Info Selection. We can see what it is already, and of course it's non-uniform, which is the default. So Effect, Reparameterization. This box doesn't show the current setting, but the last setting that was chosen. So if I switch this to something other than non-uniform, like maybe uniform accord length, and you can see how these hard edges, where there were 3 lines stuck together, 3 lines on the surface stuck together, then those now match up with their corresponding control mesh, whereas before, let me undo, you can see how those were embedded in, causing those hard edges. If I turn on shaded mode, you can see that more apparently. So I'm not quite sure why this happens this way, but this is the nature of skinning from Bezier. Now about cardinal curves. Draw a cardinal curve. You'll notice that the points, that the curve will pass always directly through the points, which sounds like a nice thing, but it can create some oddities. For instance, if I move this too close to the other one, it'll actually fold over itself. Obviously not often a very desirable thing. It also has a long range of effects. So for instance, if I move this around, you see that it affects the curve all the way up till this point here. Move that, affects all the way up there. Now in its dialog box, under Info Selection, you can change the tension, the overall tension, not for each point individually, but for the whole thing. So for instance, if I change it to 0.9, you can see how it overshoots more. And if I go back into Info Selection and set it to something really low, you can see how that changes it. If you wanted to create a hard edge, for instance with cardinal, you would, instead of bringing them close together like this, let's go ahead and set that back to the default of 0.5. Instead of bringing them very close together like that, you'd bring them near to each other, and then you could create what in NURBS you would need to drag the points almost on top of each other, if not overlapping a bit. So again, the drawback is that your nice hard edge can be ruined by the next node down the curve. Cardinal curves are useful for things like camera paths and something to do deformation by curve, where it's useful or convenient to have the curve be directly on the point, and it becomes very predictable that way. But for surfaces, it's a little less predictable. Linear curves can come in handy. One thing you can do is skin the linear curves using a different format the other direction. For instance, let's say you wanted to make a belt. We could make a shape like that, and then just go ahead and duplicate that with the D hotkey, and then move that over there. Duplicate it again, move it over there. Now maybe I want to rotate those a little bit, and then maybe move this out like that. So here I have my 3 linear curves, and I can skin them using a different format the other direction. So, surface, skin again. like this, like this. Right click and choose B-spline maybe, or cardinal, and you can get a surface like this. B-splines are the most generic vanilla format in Softimage. They're in many ways the safest format. You can always convert up to NURBS, but you can't go back to B-splines. And B-splines actually have a few advantages over NURBS. They fit tighter to the control mesh, which makes it a little bit easier to see the points. Also, they have what are called phantom points, phantom keys, and when they're in the curve mode you can't see them unless you turn that off. This becomes important later on when you want to artificially join curves or surfaces, most likely surfaces, together, and you can magnet the end points onto other objects and it looks like they're continuously joined. So if you want to make a hard edge in B-spline, what you just do is bring at least 2 points together. Note that you can also do other things with curves. You can things like cut them. So I've cut that into 2 different parts now, this part and that part. You can join them together. So for instance, I move that there, and then symmetry that in Z. I can join these together. Use draw, merge curves. You can choose to add a linear, a smooth, or to join them or to move them together. Let's do smooth, and you can join them like that. Note that the object we've created now is a Bezier curve, not a B-spline. If you join any curve other than a NURBS curve, you'll get a Bezier like this. Also, you can extract curves from other from surfaces, which is extremely useful. For instance, let's extract curve from here. Do it the one way or the other way. You get a little bit more control over the NURBS extracting, but the B-spline extracting is very fast. All other curves in Softimage are a subset of NURBS curves. It doesn't always mean that NURBS curves are the best, but they are in many ways the most powerful. NURBS curve setup. You'll find the you can set the default parameters for the next NURBS curve, whether you draw it linear, quadratic, or cubic, and the parameterization. Error tolerance is more for trimming and extracting curves later on, and angle of discontinuity is for the NURBS freeform, when it'll create a hard edge when you're freeform drawing. So default is cubic. Let's go into draw curve NURBS. A cubic NURBS curve requires 4 control mesh points before it begins interpolating the curve. And NURBS curves are the smoothest or the roundest of all the formats. By way of comparison, we can draw a B-spline over this, over the very same points, and see how it will act. Okay, I've taken out a few points here, and I'm going to turn on unselected points and lines so you can see where those are. And I've gone in here and turned on magnet on point, so I can begin laying down these control mesh points in the very same place. The NURBS curve has gone tighter and is rounder, while the B-spline is trying to get closer to the control mesh. So it's mostly for areas where you have fewer control points that you see the difference between the NURBS and the B-splines. But this is a good example of how they differ. When you add points to a NURBS curve, you have a lot of control where you don't have in B-splines and other formats. Make sure this is the B-spline, yes, and this is the NURBS. Okay. Now if you use just the normal edit, add point, middle click, and you can see how that changes the curve around it quite a bit. You can see I'll undo and redo that. If you use edit, add point, and NURBS curves, then you get the same thing happening. But if you use edit or effect subdivision rather, you can see that you can add a point of any continuity. CO or 0 would be the hard-edged, and then C1 would be a quadratic, and C2 cubic. So let's first add a cubic point. We can add that wherever along the curve, and when we subdivide, it doesn't change the curve at all. So that's very useful. And then I'm going to add a hard edge curve over here, and you can see how that acts. Subdivide. So right here, we untag those. Right here, this is a hard edge, and we added a point here, and it didn't change the curve at all. Normally, you would use the effect reparameterization feature when you're dealing with surfaces, but you can also use them on curves. So for instance, here we've made that hard edge. Well, those are actually the knots that are all put in that same place to make that hard edge. So you have the knot from this point here, from this point here, and from this point here. They're all stuck in that same place. And you can tell that if you you can't actually see the knots, but you can reparameterize, and you can see how that changes. So now we have the control in this region, and that region. Whereas before, this is more like a handle. If we use open close, draw, open close on this, it's always going to close that in a rounded way. Okay, but in the NURBS curve you have a little bit more control. You can do normal, preserve shape, or linear. Also, you can change the NURBS weight of curves, but I don't recommend it. It doesn't always give you predictable results. You go into edit NURBS weight point or tag points, and you can change it to be peaked or push away, and what this is doing is drawing the knots toward it. And you have no such control over other curve types, so this is special to NURBS. Now I'll get back to skinning Stewart's arm here. If you have lines that are going this way, what you want to do in a skinning operation is make sure that you'll be able to see all the curves as you're doing it. So if it's arranged like this, you want to make sure that you're maybe looking down it, or you have multiple windows open, you can look that way. So you do surface, skin, and when you're done, hit the right mouse button. You can choose between different formats, but most of the time you'd want cubic and non-uniform. This creates a big mass of points. The reason for this is that one of the curves has the wrong number of points. NURBS skinning will allow you to do odd numbers of points, but you get data that's really pretty unusable, so most of the time you want to make sure you have the same amount of points. One way you can ensure that you do is go into info selection and check the number of points that it says. This one has 11, this one 11, 11, and so forth. But this could take a long time. So what's another way to do it? You could open a spreadsheet window. Here, among all the other powerful queries and such, you can have access to lots of scene parameters. One of them, luckily, is the number of points in curves. So you can just go to columns and go to models, scroll down to curve info, choose curve number of point, and add that over here. Then you can move it up if you like. Now we have the curve number of points right here, and we can just check through for any that have an odd number. But you can see that this one here has 10 instead of 11, while the rest have 11. Also, to sort, you can go into sort and choose that same parameter, add that in, move it up, and you can sort so that the ones with the least amount will come first. So this is very handy. And now Now that you see that it has one fewer, you can choose a neighboring curve and then hide the rest. Then you can take a look, turn on unselected points, and just take a look down and see where the point is missing. And you can see that it's missing right there. So we'll add that in and then try the skin again. And when I'm done, I'll right click, choose default parameters, and the arm is done. Next we're going to talk about relational modeling. You turn it on right here, create modeling relation, and I'm going to hide these toes here for this turtle leg, and go ahead, select surface skin, and go ahead with the default parameters. And now if I change this to model mode, I'm going to move that icon down, and as I change any of these, the surface of the leg will update. And that same goes if I transform them anyway. Notice that the scaling, it's scaling towards its own center. You can go ahead and change that with Edit Center to Vertices, which I talked about earlier. Through scaling and translation, you have a very unique way of editing the surface this way. Also, if you should edit the envelope in any other way other than inversing it or translating it, you'll get into trouble. Upon the next refresh, it'll jump back to how all the generator curves are positioned and so on. So if I make a bunch of changes here, next time I refresh, then those will jump back. And so you have to be careful of that, or else you'll learn it the very, very hard way, like I did. I'm sure many other people did. In the course of modeling complex surfaces, especially like heads and areas with lots of tight data, you find it's very easy to make an area like this where it looks ripply and pulled. Those things are very hard to get rid of just by hand. You can go in and keep orbiting around and trying to move the points so that they don't stick out. But even then, they're very difficult to get rid of. So I'll show you a little trick that you can do. Make a duplicate of your object, duplicate immediate. On the duplicate, delete some rows. Wherever you feel like the row isn't really helping the shape of the area that has the ripples. So you'll wind up with something like this. If you then hide or ghost hide this other one, then you can see you have a very smooth surface where you need it. And although the detail is gone from there, you can now add back in those rows. It'll give you a template for putting those other points back into place. First off, you need to make sure that you haven't altered the shape too much, and check that out. You can change the object's material to something else and see how they overlap. And if you need to, you can drag the points a little bit just to make sure that you're not going to radically change the area that was rippled. So now I'll go ahead and add these back in. Turn the lines off and just use Effect, Subdivision, going in the V direction. This will only work with NURBS because of the ability you have with NURBS to subdivide and to have them smoothly maintain their shape. So keep subdividing until you have the same amount of rows again. Now I'm hiding and unhiding that to make sure I have the very same amount of rows. Also using info selection to make sure they have the same amount of rows. And although they've moved a little bit, it's not enough in the ripply area to really worry about. And in shaded mode, let's make sure that our new object is plenty smooth, which it is. Now I'm going to switch to I'm going to turn off surface. That's in show surface, and turn on magnet to point, magnet on point, all visible objects. And then in the area right where it was ripply, I'm going to go ahead and move these points and magnet them onto the other points. So this takes a few minutes and it's rather tedious, but it's a really good way to solve those rippling problems. Now you can see how I've magneted those points together, and let's see, I have the new object, and if I hide that, then my original is no longer ripply in that one area where I did it. I could do a little bit more of there if I need to. Another way you could do that would be to make a cluster key on this new object, and then save two shapes on this original head, and then keep the cluster key on the second one, and force it onto the first model. But for areas this big, it's just as fast just to grab those points and magnet them on. Now I'll talk about just a couple of alternatives to skinning. There are lots of other things you can do. First of all, let's get a circle. I'm going to extrude this rather than skin it. It's very simple. Rotate that 90 degrees. Surface, extrusion. Then I'm going to choose NURBS cubic, Y, subdivision of 6, and a depth of 15, and then leave the close option on. What that does is creates a cylinder that's capped on the top and the bottom. This is actually inverted. I'll need to invert that. I just have a hotkey of I to do that. It's also located under Effect Inverse. Here's this object, but the way that it's capped at the top and the bottom, see this is a NURBS object, is these faces. If I do info select on them, it's a face. The problem with faces in Softimage is that they can't go in envelopes. So if I create a skeleton now, inside of here, select that, do skin, global envelope, and select the chain. And I'm going to select the effector, drag that around. See, the problem is that the face won't go with the envelope. So this isn't a matter of waiting points or convincing this face to move along with this. It's faces just won't be part of an envelope. It's not designed for that. So how can you get around that? Well, I recommend just not using faces and instead going about it a different way. So I'm going to duplicate that, and instead we're gonna skin. Do a surface skin, and going to do a cubic NURBS. And at the top here, instead of making a face, going to extract. We talked about extracting a little bit earlier. Extract one there. Now we have not a face here, but a curve. We go into info select. It's a curve, and I'm going to duplicate this curve. Scale it in. Except before I scale it, let's do center to vertices so it scales right to the middle. And then I want to select that in the schematic window and do another skin. That. Right click, also cubic NURBS. I'm going to move that up so I can select its edge, and then I'm going to delete those other two curves. Select that, do draw, merge surfaces. Click on that edge, and then that edge. You can decide what kind of blend goes in between those. Smooth, smoother, or linear. See, those are the C0, 1, and 2 that we were talking about earlier. Or you can use factor and blend the endpoints, or join second to first. In this case, that's what we're going to do. Now you have a cylinder like this. I'm going to hide everything else, and now go into Info Selection and change the capping to go on the top. Now we'll close. So now we have a similar looking tube, but this one is different. This one can be enveloped. So now I'm going to Effect Subdivide it a few times so I can have something to bend with. And then just like before, I'm going to add a skeleton. Select that, skin it, global envelope, and just like before, bend it. This time, the top stays with it. Looks very similar, but now it'll bend just right with the rest. Another alternative to plain old skinning would be to use guided extrude. It's quite a powerful little feature. It doesn't work with relational modeling, but otherwise it's very nice. Well, let's start off by drawing a B-spline curve. You don't want to use NURBS with this because it doesn't work well with NURBS. So let's say we want to do an arm of some sort. Okay. So we draw one profile and then duplicate it and modify that to be the other profile, or we could have just drawn a new one with the same amount of points. What we're doing is creating two rails for the circle here to extrude up, and you get a circle, and it needs to be B-spline, not NURBS, and then rotate it. Oh no, this one you leave unrotated, excuse me, and you leave it just like it is when it comes in. Then you go to Surface, Guided Extrude, Scale Width and Height, select the cross section, the left guide, and the right guide, and you can follow the prompts down in the command output there. So what this does is creates this new surface here, which is based on this curve and those two other curves. So what happens if we now want to change this curve, for instance? I'll go into this other window. If we want to scale it, Surface, Guided Extrude. This time, instead of Scale Width and Height, we can choose Scale Width only. Select those three again. And this time, it's really wide, just like the circle was. Also, it doesn't have to be a circle. You can change that. So let's move some points here and try it again. Move back to Scale Width and Height, and this time you can see it created a shape based on this cross section. So this is a good way to make all kinds of shapes, and you can make them very fast. Now I'm going to talk about some different ways that you can model various body parts in Softimage. We've already looked at a lot of topologies you can use and ways to plan it, and looked at curves. So this will mostly be about methods and different tricks that you can use. We'll talk about making heads, making hair, some tricks for eyes and limbs and hands, lastly. So first of all, let's take a look at modeling heads. One way to do heads is to start off with a basic sphere. This is a way that I don't use very much, but would be a good option if you're doing something that's very cartoony in shape. So let's go get a primitive sphere. I'm going to change it to NURBS, cubic. Change the step in the longitude and latitude to 16. I'm going to translate it up 5 units. Get it standing on the y=0 line. Now I'm going to use the Draw Cut feature. It selected the U direction. Move that over a bit. which is the one that I selected. And if you cut once, it'll make the cut there. It'll automatically switch to the other side and cut again. And now we have a half a sphere. If we had cut along the V, so it would be parallel to the U, then we would have only had to cut once, and it would have cut it and sliced it in half. Since the U direction is capped on either end, then we need to do it that other way. So click twice on cut. Now you'll notice in the schematic window we have several. We have the original sphere. We can get rid of this, or keep this one, that half. So delete, and delete the original. Most of the time you want to start off doing only one half, and then when you're satisfied that you've gotten close, you can symmetry onto the other side and merge them back together again. In order to start out, one thing to get the overall shape, of course, one way is that you could use move point, edit, move point, or the M key, of course, and move all the points into place. It's a little bit easier to use something like a lattice. Lattice, node, create, and in this case I'm just going to choose 1, 1, 1. Move these back a bit, and use the points on the lattice to change the overall shape very quickly. I'm just going to kind of loosely move things around. And we're going to try to get shape for kind of a cartoony, simplistic character. Maybe an oval looking head. When you're done with the lattice, go into lattice, node, freeze. Now you can again edit the individual points of your object. When you're dealing with lots of points in an object, you'll want to start using proportional modeling. Edit, proportional setup. This will bring up the dialog box and turn it on. For this section here, at the top of the dialog, you have the type of fall off. Normally it's set to linear. You can change to these two presets. But keep in mind that you can also grab these handles and move them. So let's say I have a shape like this. Let's try it out in the object. If I just use move point, you can see that that exact shape is going to be replicated over the area that I've chosen. In this case it was 4 units, 4 Softimage units. If I change its area influence, of course, it's going to be smaller. The same basic shape will apply. If I change it so it's linear or pointy, then of course that shape will be pointy as I pull it out. This can come in very handy, and this is something that I use quite a bit. Also available, if you're using hatches and NURBS, is the surface area of this box. You can change it to affect a certain amount of rows in either U or V. So for instance, if I turn this up to 5 and this leave it 1, then I can move all those rows in the one direction and only one row in the other. So you can change this and see what kind of a proportional modeling results you'll get. You can either do a rectangular or an elliptic shape. You can see now that this amount of area right here was affected. You can also set it to affect only the tagged points. So if I have some tagged and some untagged, you can see how the untagged will not be affected. Also, I'll show you a trick that you can use with this. If you turn on surface, let's turn off effect tag and leave the V at 1, but change the U to something very high like 90, and then I'll go to exponential 2 and bring this out so it has a very flat curve. Move that down so you can see that. So it looks like this, and we have very high numbers in one of the boxes. So what will happen now is just by using the move key, you can change this whole row without having to select those tags. So this is much faster than having to select a row in U, select a row in V, and then go over to the translate and or rotate and move them that way. Now using proportional modeling, I'm going to come in here and change the shape, start making it like this, like a forehead area. This will be like a jaw area. Now you can start putting in the mouth and the eyes. So I need to switch to wireframe mode for that. I can turn off lines to make it a little bit easier. Like I said earlier, using effect subdivision on a NURBS surface or curve doesn't change the overall shape, which is very beneficial. If this were B-spline and you use add point, it would change the overall shape when you add localized detail. Go ahead and use effect subdivision. Now we can add that localized data. So it's chosen the correct direction, which is V. See, it's going along the V. It's parallel to the U, or the green, but it's adding detail in the V. So let's go ahead and add some detail here right about where I want to put the mouth. And we'll have a little Cabbage Patch kind of mouth here. And we'll just add a couple of lines here, and then some for the eye. Once you've established the overall shape, then you want to start adding localized detail like this. Now in full screen, I'm going to turn on the lines, and I'm also going to do effect reparameterization. We'll talk about this a little bit more later, but I'll switch to chord length, and that'll help the knots on the surface match up a little bit better with the lines that we had. Let's switch to proportional modeling. I'll go a little bit smaller here to 0.5 on the proportional modeling. Now I can begin to move points around in shaded mode. So get the mouth the way I like it. Start working on the eye. Make a little puffy eye there. Now you can look at the other side without committing to it yet by going to duplicate instance and scale that to -1. So now you can edit the one side and the same changes will happen on the other side. Now to merge these, you can either freeze that instance or you can delete it and use effect symmetry, standard way. Use YZ plane, x equals 0. Now to join those together, I'm going to move that apart a little bit so I can grab the edge, turn off lines, and go to wireframe mode. Grab the original and use draw, merge surfaces. Select that side and select the other. For joining options, you have C1, C2, and linear, or factor. What I'm going to do is join second to first. Now I can delete that. Schematic window, I can delete first half, and we're done, except for when it does join them, it leaves a sharp edge down the middle, so we can either delete those two lines or the middle line. And V. I'm going to add a nose onto this guy. Get primitive sphere. And I'm going to cut it. Draw, cut. And delete that. Scale that down. I'm going to freeze its transformations, I'm going to attach the nose to the head by using a surface deformation. Deformation by surface node create. Then click on the head. Now I can scale that in X, scale it in Y until it gets back to about the shape of the nose. Let's see where that is. It's all the way around the other side of the head, so we need to move it in X and Z. And then the Y, we want to have it probably 0 or very near 0, and then it'll be right on the surface. Okay, I'm going to scale that, and I'm going to scale that negative Y. I'm going to turn on normals to see if it's the right way. Since it's not going the right way, I'm going to inverse it, effect inverse, and then continue moving it up with Z. So if I turn on shaded mode, you can see how it's traveling along the surface as if that were its Y plane. So you get that about in the right place, and then you've got to reform it using Z, using X mostly. We'll scale it out a little bit more. Now the nice thing about doing that is during shape animation, this area here, as it's deformed, let me bump this up here, as it's deformed, that the nose will go along with it. The drawback is that it's deformed too much, then the nose will do really weird things. But for a moderate amount of deformation, this is a good option for attaching pieces on to your object. Another method of modeling faces freeform is to use the marking up on paper method that I showed earlier, and using it as a template to draw. So for instance, I have this loaded into the rotoscope wire view, and if I just zoom in here, we can begin to draw a NURBS curve in the right window using this as a guide of where to place the points. And first off, I'll do a pass in the right window, all the while looking at this other window with the rotoscope view and trying to place the points that way. And when I'm done with this curve, I'll begin to move the points in that other window. In this rotoscope window, I can begin to move points around there to match those. Now I've moved this point back a little, so his head will be a little bit deeper, and then I'm going to move the center back a little bit so that it lines up with this other point here. Now I can copy this, duplicate immediate, and rotate it on Y, and bring it about there so it lines up with the edge of the nose. Now I'm going to proceed and edit this curve so that it matches this one a little closer. To do that, I'm going to switch to the ortho view. You can do it in that view, but it's easy just to align it along the x-axis. So you see the center has been rotated, so I just clicked on X. Now I can begin to edit these points. This time the nose is going to be mostly gone because in the picture we're right in the edge of the nostril there. So I've edited this shape, brought the lip down a little bit to match that droop in the lip, and straighten this out. Now I'm ready to make the next one. Same thing, duplicate immediate, rotate. And notice I'm not doing every line, just going to generalize the shape first, then go back in later and add detail. I've roughed out this curve, but I want to bring this whole area down a little bit. It's too bulgy right here, you can see. If you use proportional modeling with curves, you want to turn on the consider neighborhood. Let's turn this down a bit to 1.4. Now this next curve, It's basically the side of his head, so it's going to be quite a bit different. We're going to need to move quite a bit of points. Let's see. We'll still use proportional modeling. Linear is good for this kind of work because you want it to straighten out. If you keep pulling the points back and forth, they'll straighten because of the linear. If I had a smooth fall off at the top, then it would be difficult to work this out with the same ease. Well, now it's straight enough in the front window, but in the perspective window you can see how it's a little irregular. What we can do then, see where the center is, and I'm going to scale it in X. Straighten that up a bit. So now I've added a fifth line there, and edited it just a bit to look like the back of a head. And you see there's a lot of irregularity in the points, but that's something we'll have to deal with later on. And you get this many, or maybe a few more. You can take a look at it skinned, surface skin. And this gives you a basis starting off, and it's not bad for just a few minutes here, roughing in a face. So now I've hidden everything else, and I'm going to inverse it. Came out backwards like that. So inverse it, and then just like before, in order to add the detail around the eye and the nose and make it look better, we'll need to add more curves. So to do that, go into Effect Subdivision, or Add, or Edit Add Point. And especially around here, of course, we're going to need a few more. You can use a feature called Frame Tag. What you do is you frame the area you want to work on, and then to zoom into that portion, do Camera, Frame Tag. Now we're looking right at that, and the interest of the camera is right in the proper place. I'm going to untag that and begin using Move Point again. Added yet another line here to define the edge of the nostril. Again, a very basic character, but with complex characters use very similar methods, just take a lot longer. So within just a few minutes, we're off to a good start on this ogre head. Another way to use templates for modeling heads is to take in a profile like this. I'm going to draw over the top of that template. Oops, turn off proportional there. So there's the first curve. You can also use the NURBS curve freeform. And for this I'm going to switch to my tablet instead. And I'm just going to draw these curves on here. Sometimes, as you'll see, they don't come out quite as good as they could. They have little oddities. But when they do work, they go very fast. Now I can parent all this to a single null. And now I can use this as a template instead of the picture, because it will go much faster. And I can begin with that as a profile curve or a new curve and build it like we built the other ones. Like I mentioned in the curves section, with a NURBS curve or NURBS surface, you can weight the surface toward the control mesh vertices. So for instance, I'll select those two, go into Edit, NURBS Weight, Tagged Points, and then drag. You can see that get pointy around it. So I can create a pointy area, or I can weight it away from it and actually push it away from the point, from the vertices. This should be used selectively, however, because it actually pulls the knots of the surface surrounding it, and so it'll actually distort the texture map right around there. But you can use it on eyelids and lips and noses and things like that to get a tight fit when you need to. Now I'm going to talk about parameterization a little bit. The one on the left here is non-uniform, and it's a little bit different than the other formats since it can really look like all the other ones. If I switch to uniform and then back to non-uniform, now it'll look like a uniform parameterization. But if I switch to chord length and then back to non-uniform, it will look like chord length. And what's happening when you use the effect reparameterization feature is that the knots on the surface will actually, these curves here, will actually travel along the other curve, and the distance between them is changed, and that affects everything from the shape to the texturing of the object. So let's look at that one more time. Go to chord length, it's the same. Go to uniform. So you can see that the overall shape stays about the same, but there are small changes. But there are pretty major changes in the positioning of the knots within the surface. Now if we look at all these together here, you can see that there are some subtle differences, and when texturing, some not so subtle differences. These three have all been assigned the same texture map. Non-uniform was left off because, like I said, that could look like any of them. And so the first one is chord length on the left, the middle is centripetal, and the far is uniform. And with a uniform you can tell how the curves were placed, and because there's lots of curves right around where the mouth is going in, so you can see how many more squares you get. This file is just a bunch of black and white checks. Sort of the idea is to get, when you're on the surface, is to get the checks as close to square as you can, because that makes for predictable texturing. So you can see that there was a big area on the top where there wasn't a curve, and so that makes for one big long stretched area. And where the eyes and the mouth have extra curves added, you can see that those are all apparent in the one on the right. The one on the left probably provides the best texture mapping. That's chord length. What I tend to do is go to chord length and then go back to non-uniform, because I like the properties of non-uniform. It's a little bit easier to edit, and the shape stays closer. And so you can see that provides the most uniform texturing. Centripetal is close, especially in the horizontal area around the mouth. You can see how that's not quite as good. So this UV texturing comes in handy for things especially like cloth, like I was discussing with the clothing, with the shirt and everything, how it was all designed so that the cloth would flow over it in a natural manner. And you also want to pay attention when you're doing things like these heads. So you want the most uniform texture that you can get. Most of the time after you're done editing half a head like this, you'll have a jagged cross section. To straighten that out, just do tag, points, row and V in the front and the back, and then make sure that the center is at x equals 0. Switch to tag mode, and then just scale to 0. Now you have a perfectly straight line up that x equals 0 axis. Now moving on to hair. This hair was designed so that the parameterization would sort of reflect the flow that I wanted the texture to take, so that you can see the not only does the form lend itself to the shape of hair, but the texture as it runs over it will take that same path and undulate in and out, and you can see that the U or base bottom line of the texture map is going to start in that sort of jagged manner, that as if it were clumps of hair. So you can see how that's going to work. And if I preview that, I've put on a UV texture map so you can see how the hair will flow over, just like these checks.